All right, so working in chapter 12, we will be simplifying rational expressions today. So you should know like rational, something that can be written as a fraction or a decimal. If the decimal would have to terminate or repeat. When we're dealing with algebra, a rational expression could be written in the form polynomial over polynomial. So some examples might be like 1 over x plus 2 over x minus 3, x squared minus 25 over x squared minus 10x plus 25. These are all rational expressions. They have polynomial over polynomial. One thing we need to keep in mind, though, is that the value of the expression in the denominator cannot equal 0. So if it was this case, x could not equal 0. Can you remember why not? Okay, so remember, we cannot divide something by 0. Can't divide something into 0 groups that exist. So in this case, x minus 3 could not equal 0. So x would not equal 3. Okay, so the value of the expression in the denominator cannot equal 0. That's an important thing about rational expressions. When we simplify rational expressions, it's just like when we simplify fractions, but it's going to look just a little bit more complex. So to simplify a rational expression, you can factor out all common factors from the numerator and denominator. So for example, a lot of times you've had a problem like 10/25ths, and you factored out common factors. You usually just did it like, I'm going to divide by 5 because 5 goes into both of those. So that's going to be 2/5. Okay, but one way you could have written it instead, and this is really doing the exact same thing, but you could have said 10 is 2 times 5, and 25 is 5 times 5, and this is all time, so I'm doing common factors, so I'm just literally canceling out the 5s and getting 2/5. Okay, I want you to notice something because this is a common problem that people do. So, I mean, if I had something like this, 3 times 2 times, or over 5 times 2, that should equal 6/10, which if we reduce it equals 3/5. You can notice that we can just literally cross out those 2's. However, if I had something like this, 3 plus 2 over 5 plus 2, that should equal 5/7, right? So you can see you can't just cancel out the 2's there. That's not allowed. So when they're factors, they have to be just all these things that are multiplied together. And if they're all multiplied together, you can cancel out the common ones from the numerator and the denominator. Okay, so let's try it. So simplify 3x plus 9 over x plus 3. What you want to do first is make the numerator and denominator, factor them out if you can. So in that numerator, we can factor out the GCF of 3, and we could call it 3 times the quantity x plus 3 all over x plus 3. Okay, if I'm trying to simplify it, x plus 3 is multiplied by 3 on the top, and x plus 3 is multiplied by this invisible 1 on the bottom. X plus 3 is a factor. The whole thing, x plus 3 is a factor. It's being multiplied by 3 and then on the bottom by 1. So it is a factor being multiplied. I'm allowed to cancel it out. Notice I'm not just getting rid of the plus 3, I'm getting rid of that whole factor, x plus 3. So therefore, this just simplifies all the way down to 3. Okay. Let's try another one. So step, you're going to want to factor first, and then you're going to want to cancel out common factors. So try that on your own, this one if you can, and see if you get what I get. Okay, so on the numerator, it's going to be 4 times the quantity x minus 5. I factored out that GCF of 4. On the denominator, that's a trinomial. I'm going to have to factor that. A lot of you are getting pretty good at factoring this. Okay, 2 binomials that multiply to give that, so I want x minus 5 times x minus 4, okay, because then you can see that's going to give me x squared and then the minus 9x plus 20, so that's good. Okay, I'm looking for my common factors, so it's 4 times x minus 5 on the top and x minus 5 times x minus 4 on the bottom. They both have a common factor of x minus 5. Those are gone. Then we have 4 over x minus 4. I have this 4 on top and the 4 on the bottom, but notice it's not being multiplied this time. It's just like a minus 4. It's not a factor in that case. I can't get rid of it. This is my simplified expression, 4 over x minus 4. Okay, let's try another one. So simplify 3x minus 27 all over 81 minus x squared. Okay, again, I'm going to do as much factoring as I can first. So I'm going to have a 3 as my GCF on the top, 3 times x minus 9. On the bottom, I hope you notice that this is a difference of squares, So it's going to be 9 minus x times 9 plus x. Okay. At first glance, it may look like there's no common factors here because we have 3 and x minus 9 at the top, 9 minus x and 9 plus x at the bottom. But what I want you to notice is x minus 9 and 9 minus x are opposites. Okay, and I'll show you 2 ways to think about this. Okay, so one thing you could do is call 9 minus x negative 1 times negative 9 plus x. On the bottom, you'd be allowed to say that, right? That is that. Okay, and then I want you to notice we have x minus 9 and negative 9 plus x. Those are the exact same thing. X minus 9 and negative 9 plus x are the exact same thing. So that is a common factor that we can get rid of now. Okay, so, and we already dealt with that. So on the top now we would have 3, and on the bottom we would have that negative 1 times 9 plus x. And probably generally we would divide 3 and negative 1 and put negative 3 over 9 plus x for my simplified answer. Okay, if you don't want to go through that work of factoring out that negative 1, but you're going to have to do it in some manner. But you could just say if we have x minus 9 and 9 minus x, those are opposites. When you cancel that out, it's just going to equal negative 1. Because then, like anytime you divide something by its opposite, it always equals negative 1. Okay, so think about it in whatever manner you want, but a lot of times you're going to have to look for opposites and it's going to get a little bit tricky. All right, try this one on your own, please. See if you can get it, check it with me. So, again, I want to factor out first at the top. So I'm going to be playing around with this top. I'm going to do this Chinese method. It's going to have to be 2 and 1 to get the 2x squared, 2x and 1x. And then for this negative 15, I probably 5 and 3. I'll try 5 and 3. Okay, remember when we did this cross product? So 2x times 3 was 6x. 1x times 5 was 5x. This will work to get negative x if this one's negative, so we want to make that negative. Okay, or you can just guess and check it, whatever method you liked. But so this should be 2x plus 5 times x minus 3 on the bottom, on the top. Numerator, and then the bottom it just has a GCF, 5 goes into it, so it's 5 times 2x plus 5. Okay, again, look for common factors. I see a 2x plus 5 and another 2x plus 5, and then all I'm left with is x minus 3 divided by 5 for my simplified fraction. Okay, here's another good one to try on your own. Okay, 9x squared minus 1 all over 6 minus 18x. Okay, so give this one a try and we'll see what happens. All right, first thing I'm going to do, hey, that numerator, that's a difference of squares. 9x squared is a square, perfect square. Negative 1 is a perfect square. So this is going to be 3x plus 1 times 3x minus 1. The bottom, I've got a GCF at 6, so I've got 6 times 1 minus 3x. Okay, this should look pretty similar to what we've seen before. There's nothing that's just straightforward a common factor. Nothing that's just obvious there. But 3x minus 1 and 1 minus 3x, they're opposites. So remember, if I reduce those, it equals negative 1. Okay, so I've got negative 1 times 3x plus 1 all over 6. That's a decent way to write your answer. If you prefer, I'm fine with you putting 3x plus 1 over negative 6. Okay, either of those for an answer. All right, let's try one word problem. Let's see how you do. Okay. So, here's a real world problem. The baking time for bread depends in part on its size and shape. Here's a good approximation for the baking time. So if you worked at Panera or something, this would be very useful to know. If you have a cylindrical loaf, it's 60 times volume all divided by surface area, or simplified, that's 30 times radius times height all over radius plus height. The radius r and the length and height of the baked loaf are in inches. So I want you to find the baking time for a loaf that's 8 inches long and has a radius of 3 inches. And then I didn't ask you to simplify your answer this time. I asked you to round your answer to the nearest minute. So you're going to be just plugging in your values and then doing a rounded answer. So we're going to use this formula, 30RH over R plus H. So we got 30. The radius is 3. The height is 8. That's all over R plus H. So 3 plus 8. Okay, so I'm just going to multiply this out, do what I can. So 30 times 3 times 8, I get 720. 3 plus 8 is 11. And then I'm going to just go ahead and that's dividing. 720 divided by 11. I get about 65. Well, I get actually 65.45 with the 4-5 repeating. But it says round your answer to the nearest minute. So this is going to be 65 minutes. So this loaf of bread would take about a little more than an hour to bake. All right, so in closure, I want you to think about what you have to be aware of with the denominator of a rational expression. If I had gone back, and I would be really precise on this, if I don't say like assume this is not such and such, if you went back to each problem, a lot of times I may ask you to actually do this. Since x plus 3 cannot equal 0, you can say that this equals 3 if x does not equal negative 3. Okay, and same thing here. You could say this equals 4 times the quantity x minus 4 if x does not equal 4, but also because of that original expression, x could not equal 5. So you'd have to set each factor equal to 0 and say, yeah, it can't equal either of those. So in this case, this would equal it if x did not equal 9 or negative 9. Okay, so I want you to just be aware you can't have 0 in the denominator, otherwise the simplifying works nicely by canceling out common factors.